All right, hope everybody's doing well today. I've taken off my tie, so my professionalism is lessened. I hope that's okay with you. Um, this section of our book, Postulates and Theorems Relating to Points, Lines, and Planes, there's not a lot that's new here, but we're going to say it in some different ways. This is basically some emphasizing some rules and as far as what you can have with points, lines, and planes, and what you can't have. Let's start here with number one. Basically what this means, the way I've sectioned this off is different than your book. I've said, okay, if we're just talking about points, here's what you can get if you just have points. If you have 2 points can form a line. It doesn't matter where those 2 points are. There's point A and B. There's a line that goes through there. There's line A and B. If A and B are pointing a different direction, well, you just have a different line. Between any 2 points, anywhere in space, they are linear. Okay? If you have 3 points, those 3 points have to be in the same plane. Those 3 points are coplanar. There's 2 other ways that those things can be coplanar. If you have 3 points, they can be linear, all in the same plane. If they're in the same, therefore they're in infinitely many planes, like we've already talked about. Or they can be non-linear. What should be non-collinear? Oh well, non-collinear and determine a plane like this. There is a plane that contains all 3 of them. This is the triangle deal we've said over and over again. If you have 3 points, they are coplanar, and hopefully that helps explain why. So there's 2 points, there's 3 points, and the things that you can possibly have. If you have 4 points, that determines space. Now this word determines means that it's like creates, it makes space. 4 points make space. They may either be planar, like these are 4 points all in the same plane, or imagine 4 points all on the same whiteboard, or whatever that you will. Or they can be non-coplanar. Okay, actually had that question on a quiz, I do believe. But if you have points, 2, 3, or 4 points, that's what you can have. If you have 5 points, you can't get anything else with that. Ways to determine a plane. Okay? This ways you can create to have a plane. You can have 3 non-collinear points. This is the exact same thing as we had up there earlier, but now we're just saying there are only 3 ways that you can possibly have a plane. 3 non-collinear points. There's the triangle that we've been talking about. If you have a line and a point not on the line, so a line and some other point, that creates a plane as well. Or 2 intersecting lines. If you have 3 points that are not in the same line, you have a plane. If you have a point in a line, you have a plane, a single plane. And if you have 2 intersecting lines, you have a plane. Okay, those are the only 3 ways that can determine that create a plane. You can have more than that in a plane, but if you have those things, then you have a plane. That's what this is about. Moving on. Relationships between 2 lines in the same plane. If you have 2 lines in the plane, they can be parallel. They're in the same plane, they don't intersect, they're parallel. These little red markings there mean parallel. Or they can intersect at exactly 1 point. If you have 2 coplanar lines, they either intersect at 1 point or they are parallel. They can't intersect at more than 1 point. That's not possible. If you have a line and a plane, number 4 here. A line and a plane can be parallel. Imagine this. Imagine the floor as a line, and then a line that's in the ceiling, like in the ceiling tiles or the corners of the wall. The line on the ceiling and the plane of the floor, they will not intersect. They're parallel. They can intersect at exactly 1 point. Okay? Imagine a pencil going through a piece of paper. Or the line can be on or in the plane. The plane contains the line. Imagine a line on a piece of paper. That would be a plane, a line that is intersecting the plane. It's in or on the plane. The intersection is a line. All right, if you have 2 planes, they can either be parallel and not intersecting, or they can intersect at a line, and that is it. That's the same diagram we've seen before. They can intersect at a single line. Now, the rest of this here Well, it's not going to be simple for everybody. But numbers 1 through 7, it wants you to draw these figures. 8 through 15, you'll just be naming some things, and then we got some true and false questions. This is as deep as section 1.5 gets. The drawing, naming things, true and false, and that's the only thing we're adding to it. None of what we've just said should be completely new. It may be presented in a different way now. I'd like for you to pause the video, do 1 through 7, and I'll come back with some answers in a second. I sure hope you've paused the video. If you haven't, do it now. Do those 7 questions. Okay, 3 coplanar lines that do not intersect. That's all you have to do to draw them. They have to be parallel if they're not intersecting, and they're in the same plane. There's a diagram of that. If you had something different, I'd love to see it. Number 2, 3 coplanar lines that intersect at exactly one point. There is a picture of that. You kind of have to draw the plane in order to determine the plane, to create the plane, and then there they are intersecting at one spot. A line that intersects each of the 2 coplanar non-intersecting lines. There we go. 2 parallel lines with a third line that intersects. I probably should include a marking here that says those are parallel. There we go. Next, 3 parallel planes. That's really just the way you draw it. Imagine a book, the front and the middle and the back page of a book. Those are 3 parallel planes, if you will. Number 5, 3 planes that intersect at one line. You can kind of imagine, the spine of a book. That if you opened up the spine of it, you can have intersecting lines at the spine, and they're all going in different directions. A plane that intersects 2 non-intersecting planes, like a book again. Oh, that was just the other example there. Number 6, 2 parallel planes with one basically this is the same as having 2 intersecting planes like I normally draw. I just had to make a parallel one there before I did it. Watch me draw this. 2 parallel ones and then one coming through it. Okay, that was number 6. Number 7. The best way I can describe 3 planes that intersect exactly one point. Draw a cube. Those 3 sides intersect at that point. Or imagine in a room, the floor, and then 2 walls that meet at a corner. That there would be that one point that is the corner, the bottom corner. Okay, pause again and give the next set of questions a shot. Here are these answers. Check them out. If you're paying attention, please write the word star at the very bottom of the page. Pause. All right, answers to the trues and false here as well. I have a feeling that you may have questions about some of these, and that's fine. Some of these questions should look familiar from our previous sections. I hope that you're seeing that, but be prepared to get these questions asked. If you have them, come see me. I'll be glad to help you as well. That will conclude most of what we got for Chapter 5. You can start reviewing now. Okay. Also, get some rest. The test is going to be a big deal. You're going to want to make sure you're well rested. Okay, bye.